All right. Uh, I believe my screen is visible. Um, yeah, let's go ahead with an overview. So what is AggLayer at the first place? What is the problem that we are solving? So currently, as you might see, with a number of L2s coming up every day, a number of chains coming up, not just L2s but app chains, L3s on top of L2s, etc. There rise a problem of fragmentation. What exactly is fragmentation? So basically, fragmentation is when you don't have when your assets, when your users are focused on a single chain or focused on diverse chains, and you don't have a concentration of users or concentration of assets or concentration of liquidity, you can say. This causes fragmentation, and it becomes hard for new dApps or new protocols to come up and to choose a chain at the first place, because they might find it hard because let's suppose a dApp wants to come to Arbitrum, and there are lots of users as well as liquidity in Arbitrum, but they don't have support for the dApps that they are using under the hood, and for that they need to use some other chains. This causes a huge problem, right? So in AggLayer is basically not a blockchain, not a data availability layer, but just a layer that aggregates your proofs from multiple chains and sends it to L1 for settlement. That sounds absurd, right? So let's go ahead and see how exactly it works by looking at a transaction in the life of an AggLayer. So basically, AggLayer is just a layer beneath all the chains connected to AggLayer. So currently, when you build a chain using CDK stack, that is chain development kit stack, you have to do some things. You have to tinker some things, tinker some contracts, and then you'll be able to connect to the AggLayer. So all the chains that are currently built on CDK, it is XLayer, it is A star ZK AVM, numerous chains that are built on CDK are connected to AggLayer. And basically, AggLayer aggregates all the proofs from all these chains. That is the state transitions happening on a single chain, state transition happening on the chain B. It aggregates both of those proofs and it settles it on L1. So how it works exactly? Let's understand this with the help of an example. So let's suppose Alice wants to send 50 USDT to Bob from chain A to chain B. Supposedly chain A is connected to CDK stack as well as chain B. What exactly it does? So let's say there is a wallet. Let's suppose MetaMask in this case, for example. So MetaMask first, to send 50 USDT, Alice wants to first initiate the transaction. Once he or she initiates the transaction, um, the local exit tree of the chain A, it basically proves that chain A holds at least 50 USDT, and that too in the name of Alice. So if let's suppose if chain A holds 2000 USDT, it is greater than 50 USDT, right? So it generates a proof for that, and it sends that proof to the AG layer. Once the transaction is initiated, the balance of the local exit tree gets reduced by 50 USDT per se. If suppose if the balance of the local exit tree is 2000 USDT, it gets reduced by 50 USDT, and the state transition of this is stored as a nullifier in the Merkle tree, and it also generates a proof of the state transition, and that proof is sent to the AG layer. It also generates pessimistic proofs showing the intent to transfer 50 USDT on chain B and updates the local exit tree of chain B with plus 50 USDT without doing anything as of now on chain B. Are you able to see this exactly draw diagram? Oh, okay. I think you're not. Let me just share that. Sorry. Yeah, I'm just sharing this. One moment. Yep, I think you would be able to visit. You will be able to see this now. One moment. Uh, yep. Yeah. Can you see this now? Akshat might.
Yeah, yeah, yeah.
Yeah. Yeah, I'm so sorry. Yeah. So let's understand AggLayer by seeing this example of a transaction. So let's suppose Alice wants to send 50 USDT to Bob from chain A to chain B. What exactly happens is first, the local exit tree of the rollup chain is verified that it at least holds 50 USDT on chain A. That is the local exit tree of the chain A, which also uh, you know uh, it has all the states of all the balances and all the states of the chain A. It basically proves that it holds at least 50 USDT, and that too in the name of Alice. Once a transaction is initiated, the balance of local exit tree gets reduced by 50 USDT, also generating a proof on the state transition. And it generates a pessimistic proof showing the intent to transfer 50 USDT on chain B and update the local exit tree of chain B as well with plus 50 USDT. So, for example, let's say local exit tree of chain A has 2000 USDT and local exit tree of chain B holds 1000 USDT. So in this case, so first what it does is the local exit tree of chain A, it first checks that it holds at least 50 USDT. If yes, it generates a proof that okay, I am holding 50 USDT and we are good to go to send a transaction. And that proof is basically sent to the AG layer. Once the transaction is initiated, the balance of local exit tree gets reduced by 50 USDT. That is from 2000, it goes to 1950, and also generating a proof of the state transition that we talk about. And now what happens is it generates a pessimistic proof as well, showing the intent to transfer 50 USDT to chain B. And it updates the local exit tree, which was having 1000 USDT. It updates it to 1050 USDT. And both these proofs are sent to AggLayer, and AggLayer basically aggregates all these proofs, not just from chain A, not just from chain B, but all the chains connected to CDK that is connected to AggLayer. Periodically, it aggregates all those proofs and then it sends to L1. And now these proofs can be verified on L1, stating the transitions are valid. So without verifying the transaction on L1, way before that, your transaction is very it has been verified by zk proofs, and yeah, you will be able to transact directly from chain A to chain B within minutes and seconds. And the the proof of these transactions, or of these state changes, it will be sent to ethereum L1. So this was just a day in the life of an AggLayer transaction. And now let's go over to the unified bridge and let's see how it works exactly. So before this, let me just head over to our Polygon unified bridge contract. Polygon ZK. So yeah, I think it's this. Yes. So this is Polygon ZK bridge contract, which is unified bridge contract, and there are lots of things here, but for this example, and for a basic understanding and overview, let's pick this bridge asset function, which will be the most that we'll be interacting with. So this bridge asset function, don't look on what exactly do we need to pass now, because we are just understanding the architecture as of now. And as you can see, um, yeah. So as soon as a bridge transaction is initiated on the source chain, and by passing all the parameters like destination network, destination address, amount, token, etc., it first again checks if what token exactly that we are sending. If it's a gas token, just directly send that. If it's ether, or if it's a wrapped version, on this destination chain you will also get a wrapped version. But if, let's say, on the source chain, if it's not a wrapped version, it's an original token, you will always get an original token, but not a wrapped version, focusing on unifying liquidity across chains. And at the end of this, we are adding a leaf to the local exit tree. That is, you can understand it like a Merkle tree. And yeah, so basically it's a Merkle tree, and you are adding a leaf of the state change that you have done. And once that leaf has been added, and once your transaction is verified on the source chain, once it has passed all the block confirmations, your the leaf will be added, and you will be able to claim it on the destination chain. So that's the whole thing for this as of now. And you can also pass a cross-chain message, a cross-chain transfer of asset, etc., etc. So now we are going to understand how we can bridge a custom ERC20 asset that will just deploy. But until this, do we have any doubts? Every chain must provide proofs for their own chain. Yes, that's correct. They don't have to, they don't have to know about other chains, because, yeah, that's the nature of blockchain. Because they don't, all the blockchains are built on silos, so they don't really have understanding of what is going on other blockchains. Yeah, by the time you type, let's start with this, and I'll answer to your questions once we are done with this. So yeah, supposedly this is a custom token that we are creating. Let's name it egg as of now. Um, yeah, we are using hard hat. We are using open Zeppelin libraries. We are using JavaScript. Yeah, and it's a pretty basic things. In env file, we have private key for our wallet. We have RPC along with their API keys, and yeah, that's basically it. So in this tutorial, I'm going to show how you can bridge egg token from Ethereum Sepolia test network to Polygon ZK EVM Cardano testnet. Let's go ahead and first deploy this token. Yeah, npx hard, hard hat and deploy CGS network Sepolia. And yeah, the token is deployed on Sepolia network. Let's check once. Mm, yeah, the token is deployed, but there have been no transactions yet. Let's keep it like this. Let's check once. Yep, the token was deployed. And let's replace this token. So we'll be interacting with this file, breacheth.js. I, I'll just go through all of this once. Give me a moment. Yeah, I just update this token address here. And here as well. Yeah. So here, just ignore this as of now. Yeah, we'll focus on the main functionality. And so basically, there is a so unified bridge is on Ethereum. That is the main unified bridge is on Ethereum, but the local instance of each unified bridge is deployed on each chain. So you can count it as number of chain as there are, let's say there are suppose 5 chains. So all the unified bridge local instances are deployed on each and every chain. That will be um, 5 contracts on in total. And so this is because you need to claim assets on other chain. So you will have to first bridge asset from the source chain, then claim hit the claim asset function on the destination chain. And basically our API service is running so that it can read to events. It can, read to the Merkle proofs that were updated, the state transitions that were updated, etc., etc. And it will. So once it is done, the we can query the Merkle tree, and we can see if the asset is ready to be claimed on the destination chain. Once it is ready, we will be able to hit on the claim asset function on the destination chain, and we'll be able to claim the asset. So that's the whole flow. And so this is the unified bridge contract instance deployed on each and every chain with the same address that is ending in 582. And the source network is basically Sepolia as of now. The destination network is Polygon ZK Cardona. And source network ID is again, you can count it as a parameter of unified bridge contract, which means that source network ID, if it is 0, it means that it is Sepolia. And if it is destination network ID, if it is 1, you can count it as it is ZKVM Cardona. It's an internal array. You can count it as like this. So this is 0, this is 1, this is 2, etc. It's an internal array, and yeah, you need to mention it like this. So let's suppose if your source network if your source network is ZKVM Cardona, you need to mention source network ID to be 1. And if your destination network is Sepolia, you need to mention destination network ID as 0. Yeah. So the destination address is basically the address you want to send your assets. So in this case, I'll keep my address only, and the token address that we just deployed, and the token amount that we need to send across chains. This is first update global exit route. That is basically, so suppose if you bridge asset, it will update the leaf node, and leaf node will basically update the local exit tree root node, and the root node will basically at the end it will update the global exit route node on Ethereum. Right. So if you want to put it as, if you want to update it like right away, you need to put it as true. But if you don't want to update, it will at the end, it will definitely update the global exit root node, but it will take some time. And so yeah, just put it true as of now, since we want to update the exit route. Yeah, here we are just creating the provider instance, and this is a wallet that we are creating with private key and the provider instance. This is the contract instance that we are creating with unified bridge contract address, ABI, and the wallet that we created. And to, yeah, this is the ERC20 contract instance. This is unified bridge contract instance, and this is ERC20 contract instance. Since we will be minting tokens first, and then we'll approve those tokens to this unified bridge contract so that it can spend it on our behalf. And then, yeah, we will bridge the asset. So this is again unified bridge contract instance. This is ERC20 contract instance. This is where we mint ERC20 tokens on our address ending in 81, and this is the amount that we are doing. I think it's 10,000. I'm not sure, 10,000 or 1,000. Let's see on the Explorer once it is done. Yeah, once we mint, we approve the tokens to the contract that is our unified bridge contract address ending in 582. And our and the unified bridge contract will basically able to spend these tokens on our behalf. Now, we also listen to the event when we call bridge asset function. And this event is basically it emits all the, you know, uh, once it let's see the contract here. Yep. Yeah, as you can see, it emits multiple things: origin network, origin token address, destination network, destination address, leaf amount, metadata, and deposit. And this same gets added to the leaf node on the local exit root tree. So it's essential to hear to this event because we will passing some of these parameters to our claim asset function, which are essential to claim our asset on the destination chain, such as deposit count. And we will also need this deposit count while we are, while we are fetching the proofs of the while you're fetching the Merkle proofs using this deposit count. And these proofs will be needing to submit on the claim asset function. But yeah, we'll come to that later on. So it's here. Yeah. So all these proofs, we need these proofs to be able to claim the asset such that our API service proves that okay, the asset is ready to claim on the destination chain because I have verified all the state transitions done on the source chain, and all the state transitions are valid. So it will generate a proof, and those proofs you will have to fetch it via our API. And once you fetch all those proofs, you need to pass it in this claim asset function so that user will be able to claim the asset on destination chain. So yeah, that was it about bridge asset function. Now I'll just tell what all these parameters are. So this is destination network ID. On which chain do we need to bridge our asset? That is, in this case, we are putting it as one. That is Polygon ZKM Cardano, as you can see here. And yeah, destination address. This can be any address, but for this tutorial, for this workshop, I'll just keep it mine. Token amount that we want to bridge. Again, I think I need to count this. I think it is one or less than one. I'm not sure. Yeah, we'll see. Yeah. Yeah. So this is token amount, token address. That is the token that we just deployed, which is this. Force update again, we just talked about this, and permit data. You don't need to pass permit data as of now because you're already approving it here. Like, yeah, here. You need to pass permit data when you are not approving, and you need to approve it when you're bridging, basically, right? So, but I have beforehandedly approved the tokens for the contract to spend. So I have to you can just put it as 0x here in this case. And yep, that's it. And it will wait for transaction for 2 blocks. You can also get the transaction hash. And yeah, we'll just talk about this later once we do this transaction. No bridges.js. Let's wait for this transaction. And yeah, first it will mint this number of egg tokens to this address, and then it will approve same number of tokens to be able to spend by this contract, that is unified bridge. Let's see, why is it taking so much time? Let's see. Yep, it has been minted here. So open this. Yep. So you can also see this egg token. Let's see this token. Yep. It was deployed 10 minutes ago. It was minted. And the token is approved again here. Yep. So basically, 81, that is us. We approved how much? I think, let's see how much it is. Again, this is U into 56. Okay. Is it showing it here? No, no. Never mind. It will show, yeah, it will show it here, I guess. Yep, bridge asset function has been initialized and the asset is, I think it has been transferred to the contract. That is our, I think oh, okay. No worries, I got it. I just copy this hash. I forgot to put TX here right after IO. Yep, I think this should work. Yes. So we just call bridge asset function on this contract. And what exactly was done is, yes. We transferred one egg token to this contract. And now, yeah, let's start with our claim thing. Also, I think you would be able to visit this transaction on our portal as well. If I have been connected, I am on Sapolia. Transactions. Yes, this transactions was just initiated, and yep, yes, this is the same transaction that we just talked here. 8 Yep. So yeah, we can also see this transaction on portal if it was initiated. Now let's talk about how do we claim that asset. So yeah, so as you can see, it takes around 15 minutes at least to be able to claim asset on the destination chain. And why is it? Is exactly it is doing block confirmations on the source chain. It is updating the leaf node of the local exit tree. And our API is fetching all those details. It is creating a proof that, okay, this state transition has been done on the source chain, and now the asset is able to claim on the destination chain. So it generates the proof. That's why it takes this 15 minutes of time. And I think it's more in the case of L2s to L2s. I'm not sure exactly. I think it's around 60 minutes when you bridge asset from ZK Cardano to, let's say, example, A star Z Kyoto testnet, which is connected to CDK, which is connected to AggLayer. And it takes around 50 to 60 minutes for that as well. So yeah, um, let's talk about claim asset function. Yeah, there are a bunch of things here we are doing. Let's start from line 114. So again, I told you that we are, fetching all those proofs with our centralized API as of now, which is hosted by Polygon itself. And we again we need to pass, what exactly proof we need. So for that, we need to pass source network ID as well as deposit count. Deposit count is basically, um, you can count it as an ID of this transaction, because there are lots of transactions happening for bridge assets. So this is basically our deposit count. And this 52152 deposit count is basically, you can count it as an ID of this bridge asset transaction, and it is mapped with this transaction, for example. So basically, to get the proofs of this transaction, you need to pass deposit count and source network ID. And when you convert it to blob, when you convert it to text again, and then you parse it, you get the payload data, which contains a bunch of things again, these many things. So basically, it's SMT proof, rollup, minute exit route, rollup exit route, origin network address, destination network, and blah blah. And so you need some of these data to claim the asset. That is, okay, sorry. Yeah, that is Merkle proof, sorry, SMT proof, SMT rollup proof, and I think global index, and we compute it like this. So it's here. And yeah, so this is some mathematical calculation as well as I would say some internal things that you don't need to care about. And yes, yep. Here again, so basically we are claiming the asset on Polygon zkVM chain, right? So as I previously said, all the instances of unified bridge are deployed on each and every chain. And for bridging the asset from the source chain, you would call bridge asset function on the source chain. But on claiming the asset on the destination chain, you would call claim asset function of the unified bridge contract on destination chain. So in this case, our destination chain is Polygon zkVM Cardano. So we are again creating an instance for provider. We are creating a wallet. Here we are creating unified bridge contract instance on Polygon zkVM Cardano with destination wallet with again a unified bridge ABI and contract address remains the same on each and every chain. So yeah, we create a contract instance and first we check if it is already claimed. If it is, then you can do any actions against it. If is claimed as false, we claim the asset on the destination chain. So again, we need to pass all this data to claim the asset on the destination chain. Wait again for 2 blocks, then it will be claimed. So I've kept a timeout of 20 minutes here. So we will probably not wait for 20 minutes for this tutorial, but again, you can try this at your home and yeah, it should work, I guess. These are the previous transactions that I did today. And yeah, that's basically it about tutorial. Yeah, let's get back to the questions. Mm, Do we wait until chain submit their proofs and then do the transfer? Yes, as of now, yes, because unless and until you wait for the proofs to be generated and verified on generated and verified, you won't be able to go ahead and do the transaction because that's otherwise because if you let's say if you initiate the transaction on the source chain and you do everything within a few seconds, then let's suppose if the proofs are not verified, then it will cause a huge problem since it does not verify that your source chain contains these amounts of funds and that is also owned by you. So yeah, we wait until chains submit their proofs and then do transfer. Yes, we do that. When we support for major testnets and mainnets on AggLayer as it in the plans for 2025. So I think there are currently 8 to 10 test networks on currently on AggLayer. I'm not sure of all the names, but some of them are A star Z Kyoto, Polygon zkVM Cardano, OKX testnet, that is X layer. Um, yeah, I'm not exactly sure of all the names that are connected currently to AggLayer, but yes, is it not all the chains, but yeah, we are doing our best to get every chain to AggLayer. Yep. I'm confused that local and global exit route. Uh, so yeah, okay. I think this should be clear by the diagram that I'll just show you. But why do we need to force update parameter? I don't understand where does the speed up coming from if we are waiting for the chains to produce the proofs before finalizing the transfer. I don't understand where does this speed up coming from if if still we are waiting for the chains to produce the proofs. I think this should be cleared by seeing this diagram. Let me just share it. Um, yeah, I think it should be cleared by this diagram. So you can see this is the local exit route that we were talking about, and it's different for different rollups. So let's say there is local exit route for chain A, there is local exit route for chain B, and all of them updates a global exit route which lies on Ethereum, verifying that this state has been updated on these chains, and please update the global exit route node as well. and global exit root node depends on the local exit root nodes. Because that is, it depends on the state changes of the L2s. So once the state has been changed in L2, a proof of that goes to the ag layer. Ag layer batches all the proofs, aggregates all the proofs. It sends it to L1, and then it also updates the global exit root side by side. So in this case, let's say suppose if you are calling bridge asset function, it updates the local exit tree leaf node. Then the leaf node is basically updating the L2's local exit tree root node, which is this. And then there can be multiple L2 local exit root nodes updated, parallelly. And let's suppose if the exit root node of chain A and exit root node of chain B is updated, and so by hashing both of them, you update the global exit root node as well, which is on L1. I'm not sure if this answers the question. Yeah, sure. I think I'll let you speak. One moment. Yeah. Hi.
Can you hear me?
Hi. Hi. Yes.
Hi. Okay, so I'm confused with something. Let me ask a question. That 12 minutes that you mentioned, I think you said 20 minutes, right? For like the time that it takes to do the transfer,
Yes.
almost.
Yes.
Okay, so is it the time that it's needed to produce the proof for the source chain, or it's for the both of the chains?
Or is it for the
For both of the chains,
No, no, no.
the proof.
Yeah, yes, it is for both. No, so to be specific, so let's say if you do a transaction, it generates it adds a leaf node, it generates a proof for that, and once the proof is generated, on the destination chain, we call that API that if the proof is generated or not, we check it, and then we pass that proof on the destination chain. No, it does not basically wait for both of the chains to update the to send the proof, because in this case we are just focusing on the source chain, which is just changing the state, because at this moment the destination chain has not changed their state, right?
Um, but the destination chain also has to have access to the most recent state of the global exit route. And so
Yes.
if they haven't produced a proof, then how do they can possibly read from the state root? So we need to wait until the agent, which is like probably the proof producer and proof submitter, to sync the chain with the smart contract on the L1, and then they read the next version of the global exit route and add it to their local exit route.
Okay, so I'm exactly not sure what exactly this API does in the backend, and because again this API is not open source, so I have
Hmm.
probably not sure what exactly it reads, but most probably I think it reads the state changes and the proofs that has been generated by the local exit tree of chain A, from which we are bridging the transaction, from which we are sending the assets, most probably. But again, this basically I think I'll connect with someone who is working on this APIs, and because it's not open source, I didn't get a chance to read on that.
Yeah, sure, no worries. Like that would be awesome. But like my main question was that let's assume that 20 minutes is for the chain A solely
Yep,
to produce
yep.
the proof, and then um, what is the difference between if I'm using, let's say, ZK Sync and like another rollup without AggLayer, I want to transfer my assets from ZK Sync to another one,
Hmm.
and because like you said, it's in the other version it takes an hour almost, and if you're using AggLayer it takes 20 minutes. But now I'm confused. If you're waiting for the proof, then what's the point? Because even in the like normal case, we are also waiting for the proof, and the proofs are probably the same. So the
So
delay also
yeah,
must be the
so
same.
yeah, exactly. So the current version, we are waiting for the proofs. We are waiting for them to get verified. But this is AggLayer V1. I don't think even if it's V1, I think it's V0. But in future, this 15 minutes would go to as good as, seconds, or yeah, fractions of seconds, because in future, what will be the state is, as soon as the proof is generated on the source chain, and as soon as it is, as soon as it says that, okay, this local exit tree is holding this amount of balance, and it is available to get bridged, the same moment on the destination chain, the asset will be minted right away, and it will not wait for the proof to be, get verified, or the local exit route of the second chain to generate the proof. And both of the proofs should go to AggLayer and then aggregate both of the proofs and then send it to L1. It will not wait for all those things. Yeah.
So I'm assuming then you later probably need to roll back the system if one of the chains did something like wrong, right?
Yes, but unless and until we verify
Because
the proof that
you
has
are
been
like,
generated by the source chain, we won't. I don't think so. We will proceed with the transaction at the first place. So
oh,
the thing
okay,
that you talked
now.
about, ZK sync. I'm not exactly sure what bridge that they use and what exactly they do. Would you please elaborate if you know?
No, it's just like a random. I just wanted to say what happens usually without AggLayer. Like you can say like any rollup, any other rollups. I didn't really want
Yeah.
to emphasize
So
on
let's
ZK
say,
Sync specifically.
yeah.
So I
So
was
I
I was
think
just
let's talk about
trying to
super chain
understand
rollups.
why AggLayer is faster.
Yep. Sure. Definitely. So basically, Agile is faster because all the rollup chains submit proofs on a single layer, and they don't have to be connected to CDK stack in future, but they can just submit their proof of asset transfer on the ag layer, and ag layer will basically check all the basically it will do all the things that we just talked about, and you don't really have to be built on top of CDK, and it can be said as, sovereign chains can also connect to ag layer. But so focusing on the current state, if you count a super chain has multiple chains built on it, right? Its base,
Yep.
mode, I think, optimism, and all of these chains. So the current, they wait for 7 days for the challenge period, right? So it's very cumbersome process to wait for 7 days. Then again, claim the asset on the destination chain, and all of those things. It goes around 8 to 9 days at the end. Uh, if by the time we remember that, okay, we need to claim the asset on the destination chain, right? So that's the case for super chain. It's taking too long, and again, all of the liquidity on OP stack chains, again, they are not unified. They are siloed in different chains, and yeah. Talking about third-party bridges, you have risks of, again, because they are third-party bridge, you have risks of them. They might also charge you some money for bridging asset across chains, and sometimes they got hacked as well, right? Due to maybe centralized relayers, or yeah, I'm not sure exactly. Uh, so yeah.
Mhm. Yeah, makes sense. But I mean, like, it's better to compare AggLayer with the ZK ecosystem, not the optimistic ones, because they have the delay issue
Yep.
whatsoever. So,
Yeah,
um,
I'm exactly not sure what exactly does zk sync do. Yeah, I'll just explore it by today, on what how can someone bridge asset from ZK stack chains, because I think they have ZK stack chains, right? So I'll just explore on this and how it works exactly, the architecture of them, and yeah, we can just compare it later on.
I think I previously have done some like small research on that, and they also do the same, like do this so similar thing that as you do. They have like a same like basically what is AggLayer to me is like a shared settlement layer for multiple chains
Hmm.
in L1,
Yep.
and in ZK also ZK era is going to be the shared settlement layer for like all the Elastic Chain ecosystem.
Okay.
And
Hmm.
that way, if you want to transfer something from one chain to another one, you just need to like post the proof of the source chain in the same contract, and the second contract has to read that proof and we read the new state from the same contract. And so basically you have the shared canonical bridge across all of them, as you do in like the
Right.
AggLayer.
Got it. Got it. Yeah,
Um,
I think I should. I'm now
but
pretty much interested on how do they do.
But yeah, like I feel like if you want to go beyond the time it's needed to produce the proof, you probably need to be a little bit optimistic about the result of the source chain.
Yeah, yep, yep.
And if it later turn out to be wrong state transition, then you need to roll back something. And also, like I have seen a rollback command like function in your source code in AggLayer somewhere. Like it was actually like doing for the do something called rollback stuff.
Yeah. So no, we currently don't have
Yeah,
that
that was.
because we are waiting for everything, to be right. So everything is right on chain A, everything is right on chain B. Okay, then we are able to claim asset on chain B. Otherwise, we won't do that as of now. But yeah, future plans are, I think you should. I'll share you a doc right away. Yeah, you should read about pessimistic proofs. Yeah, let me just. Yep, I think this, not this one. It's in the learn docs and um yeah, this is yeah, I'll just share this thing to
Actually, if you
you.
can elaborate on what is the difference between pessimistic proofs,
The difference between
between the pessimistic proofs and the actual like zk proofs. I didn't understand what is the difference between there.
so basically this is a pessimistic proof. Pessimistic proof is basically a you can see you can it's you can count it as a ZK proof, but optimistically. So basically you can say that it basically proves that it isn't doing anything wrong unless and until someone you know uh, raise a fraud proof against that thing. So yeah, maybe if you want to go in depth into it, I would suggest you to read this thing. Yeah. Mhm.
Hello, Kenan, am I audible?
Yes, yes.
Yeah, so the new CDK version that's dropping, like that has a functionality of roll-up transactions that you mentioned. All right, yeah.
uh,
Rollback, you mean?
Yeah, sorry, the rollback transactions. Yeah, sure.
okay.
You want me to share it with you or what?
No, I'm specifying that the new CDK version, the version 12 that's about to come
Oh,
up like
gotcha,
in a
gotcha.
few weeks, that will be having that rollback transaction feature that you are talking about. And I think you can try it out then. And also, as you're talking about pessimistic proof, we'll be having a session in depth for pessimistic proofs, I think in the next week or the week after that. So I think if you can join that, it'll be great. Yeah, we'll be discussing in depth on pessimistic proofs.
Yeah, a
Yeah,
TLDR would
awesome. I
be
definitely do that. Thanks.
pessimistic proofs are as good as ZK proofs, but along with some different components. But yeah, I think I'm exactly not sure what exactly is with it because we are not currently using that, and this is in a future plan. So yeah,
So to give like a
Akshat, I think you're not audible.
yeah, like a small TLDR on pessimistic. Am I not audible? Hello,
No, no, you have been breaking.
I can hear you.
hello.
Okay, I think that might be a problem
Am I
from
audible
you.
now? Hello.
Yes, yes.
I can hear both of you.
Okay.
Am I audible?
Yes, yes, Akshat.
Oh, yeah, sure. So nothing, just to give a TLDR, like pessimistic proofs are ZK proofs only, but they are for just checking that chains are not acting weirdly in the basically in the AggLayer, and they'll be using SP1's the ZKVM. There's a complete like article on our Polygon page of how the pessimistic proofs are being used using the ZKVM of sussing. So yeah, that's basic thing is ZK proofs, but they are basically doing a check on whether the chains are transacting properly and well, and that will be done through a ZK VM. So that's the like TLDR on that. Yeah.
But I mean, the statement that you're saying they're proving is pretty much the same statement that zk rollups are proving, to prove that everything that has been done in the rollup is right. So that's like the confusion for me because they look almost the same, but they have different names.
Sure, but
I
the
see.
thing
Yeah,
is,
that might be
ZK will
confusing.
directly go for the L1. Yeah, that's for the L1 settlement, right? So these are between chains. The pessimistic proofs will be between chains, and the main aggregator of the AggLayer that will be getting these pessimistic proofs from each chain. So if you can see that the three main features is the local exit route it is mentioned, and the chain's local like expected new local exit. That's what main functionality of the pessimistic proof will be for it to compute the local exit route by itself, and then whether to add it to the global exit route or not. So that's basically why ZK is being used here. And I think we can go in depth when we have that session. And I think there I'll be able to like clarify better on all your doubts. That would be great.
Okay, cool. Thank you.
Thank you so
So
much.
may I have another question, or like are
Sure,
we
sure,
short
sure.
on time
No, no,
now?
no. Please go ahead. Please go ahead.
Okay. So back in the day, I think like there was a blog post from Brandon, and I also like raised a question in another topic in this chat. So like what I understood was that the chains before producing the blocks and producing the proofs are kind of giving themselves some promises that I would include this like deposit transaction, and the other chain would promise that I will include the withdrawal transactions. And then if they don't, and the ZK proof proves otherwise, then the like chain operators would get punished for that. And like it creates some like dependency graph across the chains. And then the AggLayer job was to somehow like aggregate these proofs and then submit the like last final proof to the L1. But I didn't see this like any of the implementation related to this part in the code. I'm just wondering if it's still the plan or if we changed it, or what is the what is the case with that?
Yeah, I would say it is definitely not implemented yet, and it's definitely in the future plans, and you won't be able to see a code for that as of now. So yeah,
Hmm. But is it going to be like the plan for future?
yes, yes, yes.
Mhm.
It
Okay,
will
and
be included.
I'm
Yeah.
guessing that's where
Sure, sure. Go ahead.
and I'm guessing that's where the rollback comes to play if someone didn't include the promise.
Yes. Then if the rollback is done, the operators or node operators will get punished since the rollback was done without yeah, without. So basically, yeah, the transaction
Okay,
didn't go through and rollback went, then node operators get punished.
okay, I see, gotcha. Um, cool, but okay, one last question, I promise.
Sure.
So,
No worries, no worries.
because like aggregate is going to aggregate all the proofs at the end of the day,
Yes.
um, do the like node operators, like the proof producer of individual chains, do they need to submit the proofs to L1 contract themselves? Or is it going to be like a P2P network at the end of the day that the proofs are being handed over to aggregator, proof aggregator, and then they submit the proof into L1?
Yeah, it's proof aggregator which aggregates all the proofs, and it's not roll-up chains that sends the proof directly to L1, but it sends to the aggregator, and aggregator it basically aggregates all
Mhm.
these proofs and it periodically sends to L1.
Okay, so it's like an off-chain process that passes over the proof to
Yes,
aggregate.
yes.
Gotcha. And do you envision that AggLayer becomes a system that all of the chains behind, like all the chains under the Elastic chain can later join AggLayer instead of ZK Sync? Is it something doable theoretically?
Yes, yes. Not just EVM chains, but no, even non-EVM chains can also join AggLayer. But yeah, you can consider it as a plan for the next year at the end of the next year. So yeah, it's like let's say it does not have to be EVM chain. So let's suppose if there is Aptos and Aptos generates a proof that the transaction was done on chain A, that is Aptos, or and if the users wants to bridge asset on chain B, which is on EVM, it can be done as well because Aptos just need to submit a proof that this transaction was done, the states are valid, etc. And the Ag layer basically, it checks if the states are valid, if the proof is valid, and then the contract on basically chain B, which is on EVM, it sends equivalent amount of asset to chain B.
Mhm.
Yeah, so
Okay, cool, cool.
it's
Yeah, I
not just
understand.
EVM chains, but it will be all future chains in future.
Yeah, makes sense, makes sense. But
Yeah.
like the most like of my concern was what if there are multiple rollups and one of them is so can they like customize on the proof for
I,
aggregation within
I'm sorry, I
themselves
couldn't
and
hear your
then
question due to internet issues from my end. Can you please repeat that?
okay, can you hear me now?
Yes.
Okay, what I was saying was that what if there are multiple rollups or like L1s or whatever that have their own certain proof mechanism and proof aggregation,
Hmm.
and then they also want to join AggLayer? Can they customize a proof aggregator
Uh,
regarding that, or
No, I don't think so. They need to customize the proof aggregator. They can use the proof system that they are using. So let's suppose there is a stock proof on chain X, and they let's suppose, for example, um, so currently we accept only stock proofs, for example. So let's say if they want to verify the stock proofs, only they I believe that they send a proof that their proof is valid, that stock proof is valid, and they send that the proof is valid thing on AggLayer, and I think it would be done something like that. So they don't really have to
Mhm.
change their proof system, but yeah, they can do it with their own proof system as well.
Okay, okay, but they cannot aggregate within themselves. So the aggregation is just all completely up to the aggregator.
Yes, yes, that's correct.
Mhm. Because it adds some challenges for the ecosystems that already have some like
Exactly.
L2, L3
Yep.
architecture,
Exactly.
and then yeah, it becomes like because they are already highly optimized for their system, the proof system is probably like best for them.
Yep.
But if they want to transit like to something that is compatible with AggLayer, then it may break something. Yep.
Yep. Yes.
Okay, so it's not a good option for them, right?
Yeah. Yes. No, no, no. That's not a good option. But yeah. So as we talked, like if they have their own proof system and they generate a proof which cannot be aggregated by themselves, so um, they can just send that proof to AggLayer, and I think AggLayer aggregates
Mhm.
all the different type of proofs, and it creates a proof on all the different type of proofs that were aggregated, and then it sends to L1.
Okay, cool, cool, cool. You know why I'm asking is because I'm working at Neil Foundation, ZK sharding,
Hmm.
and we also have like almost not the same but similar architecture. We have like multiple shards, and they all have their own prover, and we have the weird like aggregation mechanism within them, and so uh, and within our system we have some component which does the similar thing as AggLayer do for
Right.
all the other chains.
Hmm.
But I was thinking, can we theoretically um like change this component with AggLayer? Is it like a um is it doable or not? But apparently, as you said, it's not because we are already like optimized for ourselves, and so that proof probably cannot be combined with the proofs within the AggLayer ecosystem, and it's not
Um,
an option. Yep.
Basically, let me just connect you with our product manager, I would say, and he will be able to explain you better on this, on what exactly you are trying to do, and is will this, can be done on AggLayer or not. So yeah, let me just
Mhm.
connect you with them. Do you
Yeah,
have
sure.
your Telegram?
Yeah, awesome. It's like Radni, Radni.
Sure. Uh, can you spell it again?
Radni.
Okay, got it. Got it. Got it. And yeah, yeah. So there are, I think, multiple things that can be done. So I think one thing is reading the storage slots of L1 using L1 S load. I think Scroll Team is doing that. And I think somehow it connects with the interoperability between L2s, but I'm exactly not sure. I haven't read much upon it. So yeah, there are multiple ways. One is aggregation ZK proofs. The second is L1S load, and I think there was one more. I think it was atomic swaps. I'm not sure.
Comic subs. What was the second one? L1 is load, you said?
Yes, L1S load. So it basically allows rollups to read the storage slots of L1, that is Ethereum in this case. So I'll just type it here. I'll share a link. Scroll L1S load. Um, I think it's this. I think it's this. Oh. uh, yeah.
Okay, I gotta check that out.
Yeah, this is some interesting thing that I'm still yet to check out. All right.
Okay, cool. Thank you. Thanks
Thank you
for the
so much.
answers.
Thank you so much for
You're
joining.
welcome.
Bye bye.
Bye bye.